Hi, my name's Richard Davidson. I'm tutoring you today about ionic bonds and ions. Now, what can you tell me about ions? Well, not a lot. They're a bit like atoms, aren't they? But they've gained or lost electrons, so they are charged, yeah? They're going to become positive or negative. Depends if they gained or lost electrons. Electrons are subatomic particles whizzing around the outside of a nucleus. So they tend to have 1 plus charge if the atom has lost 1 electron, or 1 minus if it's gained 1 electron. Okay? So, for example, sodium metal, nasty stuff. Well, if it's lost 1 electron, which it does to have a nice stable outer shell, it becomes sodium plus, which that was quite safe compared. If you've got chlorine gas, nasty stuff again, used in World War I, it becomes Cl minus because it gains 1 electron. You see, it's in group 7, so it's desperate to have 1 electron to fulfill its outer shell. So therefore, you've got 2 particles now, no longer atoms because they're charged. We call them ions, I-O-N-S. And they attract each other. Yeah, opposites attract. One's positive, one's negative. And we have sodium chloride. Yes, common salt. Put it on your chips. Put it in water. Nice white compound, ionic compound, high melting point. Salt doesn't melt very easily, but it does dissolve. Ionic compounds dissolve. Then they can carry electrical current. White compounds dissolve to form colourless solutions. No, I'm not going to drink it. If you get a ionic compound that, for example, is in a transition metal like iron, then they tend to be coloured. Iron atoms lose 2 or 3 electrons to become 2 plus or 3 plus. And, for example, you can see here, beautiful. This is from the Isle of Wight, from the cliffs there. The brown bands are sand stained with iron 3 plus. It's been oxidised. The green little bands are iron 2 plus. So you get lovely coloured sands there, yummy. You get, for example, potassium permanganate. Now, potassium permanganate is purple. So if we put it in our salty water, it's the manganese that makes it purple. We can just, not the potassium. Remember, potassium's group 1, so that's going to have white and then colourless compounds in water. But look at this. Purple rain. Well, I can't actually sing it, but you get the idea. Potassium permanganate, a wonderful dye used for showing convection currents. If I heated this, it would all go up in the air. Lovely. Now, looks like the water at the dentist, doesn't it? Probably finish you off though. Now, you can see this is one giant crystal of calcite. Notice ionic compounds with their plus and minus ions form giant lattices. If you put salt in water, then dissolved it and let it evaporate, you'd end up with growing crystals of sodium chloride, which are cubic. Calcium carbonate tend to be, well, parallelogram prisms. And so on and so on. Manganese dioxide, probably purple, I expect. Magnesium sulfate, going to be white, isn't it? Bit boring. But there are thousands of different salts, and ionic compounds, therefore, are giant structures. They're all like a big commune of ions. High melting point, high boiling point, because the attraction, those ionic bonds of negative and positive are strong to attract. And yeah, and they dissolve and carry current. All right. See you later for the next one. Bye.